not gonna show me who the best, yeah. Walk, show me who the best, get at it. Walk, show me who the best, get at it.
Hi everyone, Mr. Sam here, grade 5 teacher and creator of Graphik Universe. Today in this video, we will be subtracting unlike fractions and a mix of addition. We have 10 problems today, so let's get started. So here we have our mix of addition and subtraction of fractions with unlike denominators. Here's what we need to do. We cannot add unlike fractions. The denominator has to be the same. So we have 1/2 plus 1/4. We need to find a denominator to keep it the same. Should we use the lowest common denominator or cross multiplication? What is the best to use? Well, that all depends. It's really your choice. Here, we know that 4 is a multiple of 2. So instead of cross-multiplying and getting a denominator of 8, we can keep this fraction the same because we can just find the lowest common denominator by looking at our multiples. We have a denominator of 2 and a denominator of 4. We know that 4 is a multiple of 2. So we can easily just convert this fraction into an equivalent which has a denominator of 4. So to do that, we must multiply the numerator and denominator by 2. We will get 2/4 plus 1/4. Now we have denominators that are the same. All we have to do is simply add the numerators, and the denominator stays the same. Our answer is 3/4. Question 2, 1/2 minus 5/12. This is a subtraction. The procedure is the same, just the operation is different. So we must find a denominator that both share. We could cross multiply, but in all of these problems, we will find the lowest common denominator. We know that 12 is a multiple of 2. So we can keep this fraction the same, 5/12. We know that this first fraction, the equivalent, will have a denominator of 12. So think, how did you get from 2 to 12? We can go back to our multiples. 1, 2, 3, 4, 5, 6. We multiplied by 6. So whatever we do to the denominator, we do to the numerator. 1 times 6 is 6. We are subtracting. So now we subtract the numerators, and we get the difference of 1, and the denominator stays the same. So our answer is 1/12. Question 3, 1/5 plus 4/5. Let's look at our multiples of 5. 15 is a multiple of 5. And to get there, we have to multiply by 3. So this fraction can stay the same. That is the denominator we're looking for. We know now that the equivalent fraction, to get to 15, we multiply by 3. Whatever we do to the denominator, we do to the numerator. 1 times 3 is 3. Now we have like fractions we can add. When we add the numerators, we get 7, and the denominator stays the same. Question 4, 2/3 minus 3/6. We know that 6 is a multiple of 3. We can keep this fraction the same. We need an equivalent fraction to get to the denominator of 6. We know that we have to multiply by 2. And whatever we do to the denominator, we must do to the numerator. 2 times 2 is 4. We are subtracting. 4 minus 3 is 1 in the numerator, and the denominator stays the same. 1/6 is your answer. Question 5. 4/7 minus 5/14. We know that 14 is a multiple of 7. You must multiply by 2 to get it. So this fraction can stay the same. We do not need an equivalent fraction. We do need an equivalent fraction for this one. We want the denominator to be 14. To get 7 to 14, we have to multiply by 2. Whatever we do to the denominator, we must do to the numerator. 4 times 2 is 8. This is a subtraction problem. When we subtract 5 from 8, we get 3. And the denominator stays the same. 3/14 is our answer. Question 6. 1/4 plus 5/8. When we look at our multiples of 4, we see that 8 is a multiple. To get there, you must multiply by 2. So 5/8 will not need an equivalent fraction. We do know that to get to the like denominator of 8, we must multiply by 2. Whatever we do to the denominator, we must do to the numerator. 1 times 2 is 2. This is an addition problem. 2 plus 5 is 7, and the denominator stays the same. Question 7. 3/5 minus 7/15. 15 is a multiple of 5. 3 times 3. So we do not need an equivalent fraction for this one. We do for 3/5. We want the denominator to be 15, so they are similar. We know we must multiply by 3 to get the denominator there. Whatever we do to the denominator, we must do to the numerator. 3 times 3 is 9. This is a subtraction problem. 9 minus 7 is 2, and the denominator stays the same. 4/9 plus 3/18. If we look at our multiples of 9, 18 is a multiple. So we do not have to cross multiply. We can keep this fraction's denominator the same, so we do not have to change it. We do in fact need an equivalent fraction for 4/9. We know we want the denominator to be 18. To do that, we multiply by 2. Whatever we do to the denominator, we must do to the numerator. 4 times 2 is 8. This is an addition problem. So when we add the numerators, we get 11. The denominator stays the same. Question 9. 5/16 plus 1/8. 16th is a multiple of 8. We do not have to change this fraction. We do need an equivalent fraction for 1/8. We saw that we multiply by 2 to get the like denominator. And whatever we do to the denominator, we must do to the numerator. This is an addition problem. 5 plus 2 is equal to 7, and the denominator stays the same. 7/16 is our answer. Now, question 10. 17/18 minus 2/3. 18 is a multiple of 3 by multiplying by 6. So we do not need an equivalent fraction for 17/18. To get there, we must multiply by 6. Whatever we do to the denominator, we must do to the numerator. 6 times 2 is 12. 3 times 6 is 18. And we subtract the numerators. 17 minus 12 is 5, and the denominator stays the same. So there you have it. Subtracting unlike fractions. You can find the lowest common denominator. If you recognize a multiple, you can do that straight away. If not, you can always cross multiply any problem with unlike fractions. I hope you found that video useful. For more educational videos, please subscribe to my YouTube channel and follow my Instagram, Graphik.Universe, and Facebook @Graphik.Universe. Thank you.